All right, everyone. In this question, we are going to compare the proportion of women and the proportion of men who completed a 4-year college, or maybe more. Okay, so in this case, we've got 260 women, and we are told that 99 of them completed 4 years of college. And similarly, for men, there were 210 men and 78 completed 4 years of college. All right, so the test is whether more women than men complete college. Now, in deciding what hypothesis you're going to test, which I'm going to do first, let's fill this out part B and then we'll come back to part A. But theoretically, what matters is whether number one is women and number two men, or it's the other way around, because the sign of the alternative could actually flip if it's the other way around. So looking at what we have here, be very careful with that when you're selecting the hypothesis. So first of all, the null hypothesis should always have an equal sign. So that's equal. Now over here for the alternative, you have three choices. You have not equal, right? You have less or you have more. So two-tailed, left-tailed, right-tailed. Now, how do you decide which of the signs you pick? Well, that depends on what they wanted to test. So what I want you to do is find the word, we wanted to test that, blah, 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 or we wanted to find that. And that's going to determine your whole question. And so this is more women than men. This is called the claim, right? And so now let's find out whether this claim means not equal, less, or more. Okay, so I'm going to put women here. I'm going to put men here, and I'm putting them specifically in this order because it's going to matter. So number one is women, number two are men. Then I'm looking at my claim, and it says that more women than men complete college. Okay, so this part is going to be greater if more women, right? And then this part is going to be less. And then you draw your inequality starting at a smaller number, opening up towards the larger number. So this is going to be greater than, and this is going to be a right tail test, okay? So that's what we're going to fill out first. Okay. The next thing is to actually conduct the analysis. So let's open up on the resources that just open the regular Desmos calculator. And the first thing I'm going to do is actually come back to part A and find the sample proportions, which is P1 hat and P2 hat. Okay, so for P1 hat, which is the women, I'm going to take the number of women who completed college, so 99, and divide it by 260. Now, it tells me to round to 4 decimal places. So on the next line, I'm going to say round, and then copy, paste, Control C, Control V, or Command C, Command V if you're on a Mac, and 4 decimal places. Okay, so this is going to be 3808. So approximately 38% of women in the survey completed 4 years of college. Let's take a look at what the corresponding proportion is for men. So here I have 78 divided by 210. Okay, so let's go ahead and round that also to 4 decimal places. So looking at just a sample, because yes, we're going to do the inferential statistics in a second, but just looking at the sample, it does look like there is slightly more women, so 38% versus 37% for the men completed 4 years of college. But is this difference statistically significant? Okay, that's the point of part C and part D and all of that other stuff. But one thing for sure, it looks like there's slightly more women. This difference most likely will not be significant because it's such a small difference. So it's probably going to be our conclusion that this is, even though there is a difference, is due to chance. Okay, because sometimes that happens, right? You just randomly select people, but you're not taking everyone, you're not taking the whole population. So you are possibly making a mistake. So that's what we want to know. Is this just due to chance, we think, or is it statistically significant? Okay, so now let's go ahead and do the analysis. So I'm going to do Control-Shift-L, which if I hold Control-Shift and then press L, that clears everything. Probably on the Mac, Command-Shift? I'm not sure. Command-Shift-L, but whatever. Just want to go ahead and clear everything. Then click on the plus sign, go to inference. And at this point, because we are comparing proportions, not means, and how do we know that? Because it says the word proportion, we're going to use z-test for proportions. So we're clicking on that. And now we're filling out, and it's again very important which one is number one, which one is number two. So number one is the women, and there are 99 out of 260. Now, if you make a mistake and put them in the wrong order, so if you do that, Desmos is not going to let you continue. It's going to say, excuse me, what are you doing? Your number of successes is always less than the number of trials. Now, but in this case, you're going to click on sample 2 because you now have another sample, and this time you go 78 and 210. And then you're going to click on create test. So the first part is to go ahead and conduct testing. So we are going to expand the significance test menu. We're going to make sure that we're changing the tails to right. Okay. Now, sometimes what I do on tests is instead of P1, you actually have to select it from a choice, right? So you're going to have choices in P2. But notice how in Desmos, it'll give you that. So you can see it's P1 and P2 because sometimes people are like just flying through it and selecting mu. Remember, mu is the mean, not proportion. But it tells you that right there. So you shouldn't be making a mistake. And P1 equal P2 is the same as P1 minus P2 equals 0. All right. So we got that. We selected right on the tails. And how do we know that? Well, because we decided it's going to be a right tail test, right? And so that's why we over here, we select in right. So because it matches our hypothesis. And then we need the test statistic. So the test statistic is this called the z-score. And it's going to be right here. That's the test statistic, okay? Now, if it tells you that it wants more decimal places, you actually will need to click on the 3 dots. And this is where you have that z-score or the z-test statistic, and you can actually export it over here and then round it to however many decimal places you want. But it says 3, so I do not need to do anything. So I'm just going to say that's 0.208. That is not an unusual z-score or t-score in this case, I guess. So this is not going to be significant now. Looking at p-value, this is a pretty big p-value. 0.418, and of course it's larger than 0.05, but if you are like not sure, all you have to do is just subtract them. So take 0.418, subtract the alpha value. If the answer is positive, which it is, that means that p-value is greater than alpha, and we are not going to reject. This is not significant, this is not unusual, and we will say we do not have. So if you're not rejecting, you do not have enough evidence to complete, or sorry, to conclude that the proportion of women who complete college is what? Now, this part has to match the claim. So in the second part of the sentence, after the word conclude, you must match it to the claim that you had. And what was the claim? That more women than men complete college. So don't make up things. It has to come straight from the claim. So more women, which means that the proportion of women is higher than men, okay, who complete college. All right. The next part is the 96% confidence interval. So let's close the significance test menu. Let's open up the confidence interval menu. And we do need to change the confidence level. So confidence level, you have to watch out. It says 96. So you're going to change this to 0.96. And it gives you the interval. Okay, so let's just put that in here. All right, so now we have to interpret. And this is where we get into problem after problem after problem because people refuse to learn the cases. Case 1, case 2, case 3. I explained this in the videos. Again, one more time. What happens if the lower bound is negative? And obviously I can see that because it's a negative number. And upper bound is positive. When you see minus plus, this is case number 1. What does that mean? It means that the difference between two proportions is somewhere on this interval, but since we do not know where, it could be the negative side or the positive side, it could even be 0. It is not statistically significant. You do not really know whether P1 is more than P2 or less than P2 or maybe even equal. So you have no idea. So in this case, when you have case 1, you're going to say, we are whatever percent confident that there are no statistically significant difference. So when you see this minus plus, you are choosing the option that says no statistically significant difference. It is so easy, and yet when I look at tests, it's like, oh my God, they do not want to learn the cases. Well, there's that.